Hi, everyone. I'm Bertrand Mosso, the Anbox Cloud product manager here at Canonical. And today I will walk you through what's new in Anbox Cloud 1.29.0. This is a minor release, and with 1.29, we focused on three main areas: faster instance workflows, more flexibility at runtime, and a cleaner future-proof deployment foundation. Let's start with instance management. The first major addition is instance copy support in AMS. You can now clone an existing instance very easily, and this operation is near instant because it leverages ZFS copy and write rather than full data duplication. So this matters because it can drastically reduce provisioning time. Also, it minimizes your network traffic, and it scales really well with very large data sets. So this is useful if you are working on test and staging environments, if you want to do some rapid experimentation, or if you have high density deployments. Closely related to that, we now support publishing instances as images, which means that you can capture the full file system state of a running or stopped instance and turn it into a reusable image. So this allows you to have custom-based images with pre-installed software. It also means faster startup times for application-specific workloads and a cleaner CI and automation pipeline. So this is something that many users have been asking for, and it does significantly improve your developer productivity. Next, we added runtime control of WebRTC bitrate. So this means that applications can now dynamically adjust their minimum and maximum bitrate. So this means per application optimization. It also means reduced bandwidth usage and lower operational costs, especially if you run at scale. More importantly, this is done at runtime, so there's no need for restarting instances or sessions. We also improved how AMS handles disk quotas. So the scheduler now uses a two-tier validation model, which avoids false disk exhaustion. This is super useful, especially if you're using ZFS. Two key points here. There's a new no disk reserved flag that allows controlled disk overcommit. And we included a mandatory 5% physical disk safety margin that is enforced to keep nodes stable. This means better disk use, higher node density, and fewer scheduling surprises. That's it for the release note, and I will let the team present more in detail some of these new features. Thank you for watching.
So, two new features we have added to AMS. The first one is the copy command. So in the AMC CLI, you now have a copy that basically allows you to copy an existing instance and to duplicate it. For example, if you have done changes to an existing instance and you want to have another instance with the same kind of content, you can now use the copy command to do so. To demonstrate this, I've already prepared one instance here called test0. If we look into this, it's a normal Anbox instance, but for demonstration purposes, I'm going to create a file in the home directory of the root user here so that we can verify once we have copied the instance that it has been actually copied the instance on the node. So there's a small file called test in the home directory. If you now go out of this and we run the copy command, and we want to copy the existing instance test0, we want to give the new instance the name test1. It will now ask us, in order to perform a copy, should it stop the running instance? Because it's not possible to copy an running instance. So we basically now go stop the instance, and then AMS will internally perform the copy operation. Under the hood, if a copy is performed on the same LXD node, it will do copy on write on the underlying ZFS storage pool. So the copy itself is very quick because there's no actual data being copied. And you see now we have the second instance, test0, and if we start, test1, and if we start test1 and look into its root directory, we have the file called test, and test contains foo. So yes, we have actually copied the instance test0. We can do the same as much as we would like, as depending on capacity we have in the cluster, and we can also copy instances across nodes. Yeah. So the second thing which we have added is what we call the publish command. The publish command basically allows you to create from an instance an image. So we provide with Anbox Cloud a set of default images, but if you want to create your own, derived from those default images, for example, by doing customization or other things, you can now do so. The publish command takes as input the name of the instance we want to publish or we want to create an image from, and then we have to give the image a name. So I'm calling it here simply my image. And then what happens under the hood is that AMS takes the image, it packages it up, it converts it into a tarball, and then makes it available on the underlying LXD cluster, which will take a bit longer than what you would do with the copy command, because it doesn't use copy on write, but it allows you to redistribute that image across multiple nodes much more easier. So if you have changes to the image, you can now easily package them up and make them just available. So as this is taking a while, you can have a look at the actual image now. There we go. So the image has been created. It's now available, and we can use that as normally with any other image. So if we use test3, we use my image, then we create an instance test3 with the new image we have just created.
Hello everyone, I'm Gary Wang, a software engineer from the Anbox Cloud team. Today I'd like to introduce the bitrate control features introduced in the Anbox Cloud 1.29 release. Starting from the 1.29, we've added two config items to the WebRTC platforms: Stream Video Bitrate Min kbps, Stream Video Bitrate Max kbps. Those two config items can be used to interact with the HTTP endpoint exposed by the Anbox runtime to fine-tune your streaming bitrate on the fly. As you can see, there has been a session created up front. Let's join the session and enable the developer tools. To change the bitrate settings on the fly, you can send the standard patch request to the platform endpoint, for example through the curve command. Once you enter that command, you can check the Anbox log. You probably see the following lines, which reflecting the bitrate adjustment on the WebRTC platforms. And also you can issue the get method to the same endpoint to view the current bitrate settings. And also, if you want to restore the default values, you can issue a delete request with the specific config items. For example, if I'd like to restore the stream video bitrate minimum kbps, I can do it like. So with this, when we check the current bitrate settings again, the minimum bitrate settings has been restored to the default.
Hi, my name is Stefan. I'm a software engineer working on Anbox Cloud, and today I want to demo some of the nifty features that we've added in the 1.29 release. The first feature that I would like to demo is how an admin or another user with specific entitlements and permissions can add other users and manage them inside groups. So for this, I will add the current user to the admin group. We'll navigate to the groups page. Here we can choose, for example, a group like ODZ all permissions. We can see it has 6 permissions. We can edit the group, and we can also add users' identities, to be more specific, to this group. So we can add these identities, for example, save, and the group updated successfully, 4 identities updated. If we go, we can see it reflected here under identities. So all permission has 5 identities. We can directly click on it, or alternatively, we can go to this pen edit button and edit identities. And now we can add, remove, and manage these identities from this group. Another nifty feature that I would like to present is creating entitlements and permissions and fine-graining them to whatever resource we want. I will go to groups, select a group, for example, this one, or the all permissions, edit the group. And here you can see that we have edit permissions, where we can fine-grain whatever the users in this group can do. Like, for example, they can view the application called test, they can view the application called test2, and they can delete the application called test2. Now we can select, for example, a resource type. Let's go for an application. We'll see listed here every application. Let's go for test2. And we can select can edit, can delete, can publish, or can view, specifically for the test2 application. So we'll go, for example, for a can delete, which we can see that already exists. It's this one, can delete, can view. Let's remove the can delete permission. We can save. We'll see that the group updated successfully. And in order to actually see this, we'll remove the current user from the admin group. But bear in mind, the current user will be part of the ODZ all permissions. We can go to applications. We can see test2 because of the can view permission. And we can't delete because we just removed that permission. You do not have permission to delete this application. We'll do the reverse. So add to the admin group. Again, we can see there is another application if we're admin, but if we just stick to the other group, we can only see test2. That's because if we go back to groups or the all permissions, edit permission, we only have can view on test2. We can go ahead and add a can view on test1 and a can delete permission on test2. We'll save. We can remove ourselves from the admin group. Go back to applications. Now we can view test because we added the can view, and you can see the button has been enabled for deletion on test2. That's because we can only delete test2, but for example, we can delete test1. Now I would like to shift the focus in order to see what the users can do, can see, and can act upon based on their entitlements. So this user is inside a group where they do not have access to see or to do anything related to instances, which is why they will see you do not have any instances. Let's add this user to the admin group. So now we can see there actually are instances, but the group where the user belongs to does not have access to them. Let's go to groups and change that. We're talking about the ODZ all permissions group. We'll edit permissions. We can select a resource type, which was an instance. We can see both instances. And for example, let's go with a can view entitlement. and a can delete entitlement. We'll save. We'll see that the group update is successfully. We'll remove the current user from the admin group. Now we can go to instances. We can view the instance. We can delete the instance because we just added a can delete permission. But you'll see that we cannot create images and we cannot edit this instance. If we go back and add again to the admin group, let's go back to groups, or see all permissions, edit permissions, instance. And for example, we can go with a can edit permission, save, remove from the admin group, back to instances, and now you can start the instance. Same thing can happen for the applications page. For example, in this case, this user does not have permission to delete this application, so you can see a pop-up that says you do not have permission to delete this application, but the group where this user is has the permission to edit, which means that when we click the edit button, we can see the edit page. If we change this, and for this, I will add this user to the admin group. We'll go to groups, all permissions, edit permissions, and we'll remove the can edit permission from application and add a can delete entitlement. We'll save. We'll remove the user from the admin group. And now if we go to the applications page, you can see they are inverted. This user can no longer edit this application, but they can delete. Like you've seen, we can now edit permissions inside groups. We can add identities inside groups. We can fine-grain the permissions, and then users can only do specific actions based on the entitlements that we are setting in this panel. And this basically concludes the fine-grained authorization support for the 1.29 release.